Hello, future sheet metal super technicians. This is Jay, friendly neighborhood A&P instructor, and we're going to open the conversation on making bends in sheet metal. You betcha. We're going to take care of this step by step with each other through these videos and in class so that you can make the beautiful bends. Now, the first thing when you open a conversation about bending sheet metal that we need to be aware of is this shape right here. That's poorly drawn, but I think we all get it. This is a circle. All bends that we make in aviation sheet metal and in other industries are going to be based on this shape. So before we move forward, let's take a look at this shape. And if you remember correctly from all your mathing, a circle has 360 degrees. It's a wonderful thing. What if we divided it in half? Well, if we divide it in half, only 180 degrees. What if we divided it in fourths? Well, if we divided it in fourths, we'd be dealing with 90 degrees. And I think this is kind of getting your mind headed in the direction, because the fact of the matter is every bend we make in aviation sheet metal is going to have some curvature in the bend, and that curvature is called the bend radius, and the radius is simply based on how big of a circle are we going to bend this metal around. The degree of bend is going to be determined how much of this circle will we form our metal around. In this instance, from here to here, that's 1/4 of a circle. That would be 90 degrees, and that's the basis for a 90-degree bend, which is a very, very common bend in this business. Now, we make bends of all degrees, but 90s do occur frequently. So before we move on, just remember all of our bending is going to be based on a portion of a circle. Now let's take a look at the type of bends we can make. If we make a bend such as this one, and let's call this one 45 degrees. Now it may not be perfectly drawn, but we're all getting it. That's a 45-degree bend. That means from this point on the leg to this point on the leg, if we measured it, there's 45. Obviously, if it was straight up and down, that would be a 90. What we're more concerned about right now is what type of bend this is. This is classified as a closed angle. Now, what makes it closed? Well, it's simple. Anything less than 90 degrees between the legs, and the legs is each of those lines, anything less than 90 is considered a closed angle. Now, if it was exactly a 90, as indicated by the little mark there, then it's no longer closed. This angle is considered simply a right angle or 90 degrees. I bet you know where we're headed. What if I have an angle way more than 90 between the legs? Let's call this one, let's call that 135 degrees. That is considered an open angle. I forgot to label my top drawing here, so we're going to consider that a right angle. And an open angle is anything more than 90 degrees. So we have three different types of angles with the right types of labels at this point. Now there's one other thing I want you to observe. What if we just have a flat line, but there's no bend? Wouldn't that be the same as that portion of a circle up here? That would be 180 degrees, or no angle. For our intents and purposes, that would be the four options that we deal with when we're determining the degree of angle. It's either going to be open angle, closed angle, right angle, or no angle, also known as flat. You know, Jay, why did you show us this flat stuff if it stopped bending? Well, it's good to know the origin. It's good to know why things work like they work. The FAA is going to have questions that you need to solve, and they're pretty straightforward. And it may look something like this right here, and we've already kind of discussed this, so this one should be pretty easy. If we have a closed angle of 45 degrees, how many degrees did we bend that through to arrive at 45? Well, there's an easy way to handle that. We know that a flat line is 180 degrees. That's a constant. So if we subtract our closed angle of 45 degrees from 180 degrees, the remainder is how much we bent through, how many we bent through in degrees, which works out to be 135 degrees. So the portion that we bent through to arrive at a closed angle of 45 started flat, came all the way over the top, past a right angle, kept bending to a closed angle. We would have had to carry that metal through 135 degrees of movement to arrive at a closed angle of 145 degrees. That's why it's important to know that flat is 180 degrees. We use it as a basis for measurement. Let's do one more just to make sure we're super fast and super efficient. This time we're going to have an open angle, and once again we're going to use 135 degrees. Why? Well, I know the math and I like it. It's just a cardinal angle. The FAA is going to want to know, in order to achieve an open angle of 135 degrees, how many degrees were we required to bend? Once again, we'll set our flat at 180 degrees. We're going to subtract 135 degrees. And in this case, we're going to end up with, guess what, 45 degrees. So as a quick review, all bending math is based around degrees of a circle, either how many degrees we're going to form the metal around, or the size of the circle, and the size relates to a very important key factor called the radius. We're going to discuss it later in more detail. But the size of the circle sets the radius of the bend. The number of degrees that will follow will determine our bend angle. We have open angles, closed angles, right angles, and then flat. And then you may have to do a little math to describe to the FAA how we ended up with these numbers. Practice this, hit pause, replay. I will cover this more in class as needed. But for the time being, do good work, be safe.